So this is experiment number 6, SCR controlled half wave rectifier and full wave rectifier using RC triggering circuit. So this is a part of third semester Electronic Devices and Instrumentation Lab 18 ECL 37 under the ENC department. I am Mr. Manjunath KM, Assistant Professor, ECE Department, RVITM, Bengaluru. So the main aim of this experiment is to study the performance and waveforms of half wave rectification and full wave rectification by using RC triggering circuit. The major apparatus required is as follows. We require one SCR. So we are going to use a TY604 type of SCR. It is required for both half wave and full wave rectification. Then we require one transformer with the range 230 volts to 12012 step down transformer. Then we require one two sets of CRO probes to observe the waveforms. Then we require 5 diodes BY127. The same diode can be used for half wave rectification. Power resistor with rating 100 ohms per 20 watts, and a normal resistor 100 ohms and 3.3 kilo ohms we require, one each. Okay, and we require one DCB and a DRB, decade resistance box and decade capacitance box, and one DC voltmeter which can range which can measure up to 30 volts, from 0 to 30 volts. So this is all apparatus required. And the theory part, as earlier explained, there are some disadvantages associated with the R firing circuit, because of which we will go for RC triggering, wherein which we can instead of restricting ourselves for limitation up to 90 degree, which was there in the R triggering, R firing circuit, where we can overcome that to 180 degree range with the help of RC firing circuit. So this is all already explained in the theory part in the class. Okay, so we have actually two different circuits. First and foremost, we have half wave rectifier using RC triggering circuit, which you are supposed to do. So the procedure remains one and the same. I'll just show the circuit. This is the actual circuit what you are supposed to do in the experiment. Okay, so this circuit you can just see here. Across this 100 ohms, we are going to measure some DC voltmeter through the DSO. Actually, instead of CRO, we are going to use DSO. And we have one SCR which is of TY604 family, and we have DRB and DCB. You can connect it here, and we, for safety purpose, we use this 100 ohms resistance. And this diode is very, very important to trigger the SCR because it is connected to gate. Okay, so and we are going to use this step down transformer 12012. And that is why this circuit is very important for half wave rectification, which is controlled. Okay, then you can see the waveforms here. You will get some input voltage waveform where we are going to give 12012 24 volt peak to peak voltage, and you can see here you will be able to see two different waveforms, one across this just to show you, one across this 100 ohms power resistor, and one more across this anode to cathode. If you want, you can just measure across this SCR. Okay, so these two waveforms are very, very important. So now across this resistor, power resistor, you will be able to see this kind of waveform. Please make a note of it. And across this SCR, you will get this kind of waveform. You have to make a note of it. Okay, so similarly, you have to make observations for voltage output across this power resistor and voltage across this silicon controlled rectifier. That is very, very important. So that is after measuring all these things, okay, or after seeing the waveforms, you are supposed to measure some of the values like peak to peak voltage, then what is this VDC voltage, and some other readings. So that tabular column I have just put it here. Your main observations needs to be output across this power resistor, that is a VDC. You have to tabulate this. Okay, this is VDC because this is a DC output voltage. AC to DC converter is called as rectifier. What is the value you have to observe? Similarly, that is theoretical calculations you have to perform depending upon this formulas whatever I have given. Okay, so if it is half wave, we have 2 pi here, but if it is full wave, we will be getting pi. So this is what you are supposed to do in the experiment. Finally, you have to tabulate the readings. Okay, and you should see that theoretical and practical practical and theoretical values are almost matching. Okay, then later you should verify the same half wave rectifier using RC triggering, and you should see that more than 90 degree it is achievable, and maximum up to 180 degree, means you can get up to 0 to 180 degree control. Okay, so that is what you can observe from this RC triggering experiment. Okay, so this is whatever I have explained now. The same thing is given as a procedure here from 1 to 10 points. You can just go through that. Then coming to full wave rectification, same thing. So second part of this experiment is full wave rectifier using RC triggering circuit. So the same procedure will continue. You can make a note that only one change is related to the theoretical output voltage, that is a DC voltage calculation. I'll just tell you that. So here only this part will change, means instead of 2 pi we have only pi. That is the only change what you can come across with the full wave rectification. And in terms of circuit, this is the actual circuit. Across this again power resistor 100 ohms, we will measure the DC VDC output voltage, practical output voltage. Okay, or it is nothing but V naught. Okay, and similarly across this anode to cathode we can measure one more output voltage, which is called as VSCR. Okay, so apart from that we have same thing DRB, DCB, and for safety purpose we have 100 ohm resistance, and this is 4 diode concept for full wave rectification, and we have 12 24 volt peak to peak. So this is all about the circuit associated with the full wave rectification, and we have controlled full wave rectification by using SCR, which is triggered with the help of diode. Okay, now the same after connecting the circuit, you can observe these kind of waveforms. This is V naught, which is nothing but VDC. Okay, which is observed across this power resistor. Okay, you will get full wave output like this, and you can see the SCR output, which is the remaining part. So these kind of waveforms you should observe, and you should see that even here also you can control up to 180 degrees, 0 to 180 degree control, and you have to tabulate these many readings. Okay, practically whatever you are getting you have to observe from the DSO, and you have to calculate this theoretical value also with the help of this formula. And this tabulation is very, very important, and this is required from this experiment. Later what you can do is you can just go for the expected graph. Okay, so this is same thing whatever I have told now, same thing is explained here in the procedure. So after doing this much of thing, that you can just plot the graphs, waveforms, and you can observe that theoretical and practical values are absolutely matching. So that is supposed to be done, and only main aim of this experiment is you should know that using R firing we can have control from 0 degree to 90 degree, but using RC we can get up to 180 degree. That is, range will increase from 0 to 180 degree. So that is very, very important, and that observation you have to do, and performance and waveform observation also you should do for both half wave rectification and full wave rectification, which is controlled with the help of RC triggering. So this is all about the experiment. Thank you.